All right, welcome. Thanks all for joining us today. Hope you guys enjoyed lunch. My name's Brad Ballou. I'm a chief engineer at Booz Allen Hamilton. I'm a chief engineer for cloud security. Before I introduce our speakers today, I just want to talk a little bit about what Booz Allen does for the federal government and AWS. We have hundreds of certified AWS solutions architects, and we recently just completed the acquisition of Aquilent, which actually brings together two AWS Premier consulting partners with a number of competencies under our belts. Some of the work we do every day for the federal government helps our customers become more efficient, migrate to the cloud. And one example of that is that we recently co-sponsored and hosted a Data Act hackathon. And so this leveraged some of the newly available open source data around federal spending and contracts and some AWS services and data science to help identify ways that the government can be high performing and more efficient and effective. So if you want to learn more about Data Act or other work that we've supported, you can come by the Booz Allen booth. Or tomorrow we'll actually be giving a session on the Data Act hackathon at 11 o'clock. So without further ado, I'd like to introduce CJ and Jen.
Thank you.
Thanks.
So I'm Jen Gray, and I work with Amazon Web Services Security Assurance and Compliance Program. I oversee our North America public sector programs, which include our FedRAMP, DoD, state and local government regulations. So today we're really excited to have CJ here for our fireside chat. I have some really great questions for him, and hopefully it'll provide you some really good insight into the security of AWS and also the security services that are available for customers today. So we're going to get right into this, CJ.
Okay.
CJ, you're the Deputy Chief Information Security Officer for AWS.
Mm-hmm.
By introduction, can you perhaps tell a history about what brought you to AWS and the types of things you do today?
Sure, glad to. So my story goes back a little bit over 10 years. About 10 years ago, myself and actually our CISO, Steve Schmidt, and a handful of others that are part of the security organization at AWS, we were running an organization within the FBI. That organization was very responsible for every piece of digital media that came into the US government went through this agency so that we could cross-correlate it against other things that we had for counterterrorism purposes. And as you can imagine, it's a pretty stressful job trying to find the needles in the needle stack. As part of that, what we had to do is we had to continue to build bigger, better, more efficient data centers in order to do that. And over a few years, we did exactly that. I think we were on our 5th generation of the data center, or the data centers, about the time that we started looking for other technologies. So we sent our chief engineer and a couple others out to the left coast, the west coast where all the technology is, or at least that's where we thought it all was. And it turned out to be true. Many of the providers that we spoke to out there were willing to sell us more hardware and more software. Unfortunately, we had a lot of that, and what we were looking for was new technology. But one company that we spoke with, or that our team spoke with, seemed to have the technology but didn't really have the wherewithal to understand how to deal with the federal government, much less the environment that we were coming from, and a highly classified one. But they turned out to be a lot better salespeople than we were. Over the course of 6 or 8 months thereafter, rather than us talking them into building this capability for the government, so that we could actually use elastic scaling and things like that, they talked a handful of us into coming to work for AWS. So the beginnings of what became AWS Security a few years later started by us, the handful of us at the FBI needing the capability that AWS provided, the elastic scaling capability to be able to scale up many thousands of instances, on Friday at 4:30, when invariably the truck with many hard drives would show up, and there would be one piece of data, one needle in that needle stack that would, keep bad things from happening to good people. AWS was the company that had that technology, and using that kind of persuasion, they talked us into to coming on board such that someday we would be able to provide that capability back to the government so that we can keep bad things from happening to good people. So that was 10 years ago. It seems like it was yesterday. Literally flew by.
So rather than holding the one big questions toward the end, I thought we'd jump right into it. How many customers that I speak to constantly ask me, what does your security leadership think about? Like, what keeps you up at night?
So normally it's my dog or my daughter, but no, seriously, I don't think you guys care about that part. I think the one thing that over time that's come out is that customers don't understand our shared security responsibility model. That's something that early on, going back, say, I guess 8 years or something like that, maybe 9. One of the things that I was made responsible for is taking all the questions that we regularly get from customers and coalescing them into a document that ultimately could be shared with customers so that they would get the answers to those questions. Started out almost as a frequently asked questions type of doc and then turned into a security white paper. Still exists in a many more pages version today. But I think as we are going from the first to the second version of that, we started having this epiphany, I don't know if you'll call it that customers weren't sure as to what their responsibilities were in the cloud. Was it that you put stuff in the cloud and AWS took care of everything, or was it that they still were responsible for things? So the idea of a shared responsibility model or a shared security responsibility model was introduced at that point to make sure we could explain that. And how this model works, the easiest way that I explain it, and it may not be that easy, but we'll see, is that which you as a customer have access to, you have some responsibility for, and that includes in the security space. So in my case, if I'm on the AWS side, from the concrete of the data center floor all the way up to, we'll say for in the case of EC2, up to the hypervisor of that instance is my responsibility. You have no access to it. Therefore, we shouldn't hold you accountable for any of the security protocols and procedures that go along with that. That's on us. And that is our responsibility, and that's security of the cloud. Then customers have responsibility for those things above that in some cases. That which you have access to. When you start up a new EC2 instance and you do your exchange, and now you have sole access to that EC2 instance. You've gone ahead and set up your security groups. You now have this instance. At that point, we're not in a position to be able to do security on that because you now have the only access to it. We can't do patching or other types of things for you. Why this keeps me up at night is exactly that. If customers don't understand that once they've launched these instances, that they have responsibility to patch them, you can be in a situation where you have unpatched virtual machines that are running in the cloud, that when something like WannaCry or something like that, those types of exploits come up, then you have these instances that potentially can be had. That's not a good customer experience. Some of the things we do up front to try to prevent that is, every instance that you launch, those virtual machines comes up with a default deny all firewall, meaning we're blocking everything unless you open it up. That's what a security group is an allowance list. It's a list to allow you into or allow whatever you choose into that instance. In the case of WannaCry, by default, SMB would be blocked unless you chose to open it. And we did have customers that chose to open it and didn't patch properly and therefore had issues. And we do everything that we can in order to support them, make notifications when we see this type of activity that's indicative of these types of things. But really, that's the kind of thing that we continually run into. One of the other things, just real briefly, I don't want to go too long because I know we have many more questions to go through. But one of the other parts there is that we've also seen not only the WannaCry type of things from an EC2 perspective, where we've had these situations. Our storage service, S3, even RDS and Elasticsearch. Many times when you initiate or you place data, you have the choice of what the privileges or what the access controls are on that. Once again, it'll default down to no access. and then it increases, and you can adjust it by policy or otherwise in order to open it up more so depending on your needs. And we do have the ability for you to open it up worldwide to the internet. Not recommended, but still there, because sometimes that is actually what customers want and need. So what we really, what we see or have seen is that people will take advantage of you opening things up and leaving it out there for others, for everyone to see. And we've seen more of that in the ransomware type of space, where if you open something up and put it out there, someone with nefarious intentions will go ahead and either delete it and then put a note in there saying we've encrypted your data, and if you want it back, pay us. We've seen a rash of that. So we have, as much as we can, proactively tried to assist in those cases. But it is one of the things that, if you say what keeps me up at night in that space, that's probably the one thing, is making sure customers realize there are some things that are their responsibility still, and that they should make sure as they're working through into the cloud that they understand what those things are. And we are here to help you. It's not as if we're leaving you out there in the dark. We have tools and other things that I'm sure we'll have a chance to talk about as we go on.
Right, so you mentioned about the WannaCry ransomware, and you've described the shared security responsibility model. Does AWS, you talked a little bit, you touched on how AWS helps customers with that, but does AWS help customers even though the responsibility lies with them?
So yeah, absolutely. So we have, if you look at, our pace of innovation over the years, which just, from a security perspective, you would think is, crazy to try to keep up with. Last year we launched just over 1,000 features or large, our services or large features. And about a third, actually, I think it was almost 37% of those were security or compliance in nature. So we're always trying to up the bar, provide better capabilities to you to take away that undifferentiated heavy lifting I'm sure you've heard so much about in the last few days. In doing so in the security space as well. We continue to offer more services and capabilities in order to make it easier for you to operate or to secure in the cloud itself. Some of the things that we have various different services that have come out just to help you in that case. EC2 Systems Manager is one that actually would help you in some of the WannaCry or some of these other situations to make sure that you are patching, to make sure these things are being done. So there are features and capabilities built in or add-ons that allow you to do a lot of that. So,
I think many customers understand that we have a great security and compliance services and features. What expectations should customers have about the cost of cloud security? That comes up frequently.
Yeah. So cost should never be a barrier to having a secure cloud environment. A lot of the things I just talked about cost nothing. You get your firewalls or your security groups and things like that are part of the service natively. So you don't have to, there's no additional cost in that space. Many of the services that we have that if you talk about virtual private cloud. So virtual private cloud, kind of hearkening back, was the very first service and capability that the team that came over from the FBI created. So we created this virtual private cloud environment because if you think about it, coming from the government, we wanted to be able to slice off a piece of the cloud and use it for our own purposes. So what VPC is a logical isolation of the cloud, so a logical network isolation. It allows you to have an enclave within that cloud environment that you carry your own IP addressing to. So obviously from a networking perspective and otherwise, it's isolated. So when we're looking at it from that perspective, you can actually create these environments, have that isolation, and do so for very little money, if at any cost at all. So, from that standpoint, the features that we launch in the security space are intentionally designed around trying to make sure you have a good experience in the cloud and that it's a secure one across the board.
So we talked a bit about what customers can do. Mm-hmm. I'd like to come back towards the end and talk about the shared security responsibility model. But what many customers, when my team and I speak to our government customers, is they have a lot of questions about what AWS does. I cover the compliance programs in our North America region, and one key topic that comes up is the supply chain risk management. How does AWS think about and address this topic?
So this is an interesting one, and we could have, a several-day dissertation going on here, so I'm not going to hit on all the points. But literally, we'll split it into two kind of general areas, because supply chain, which used to be, and for many of us coming from the Department of Defense or that background, you always think supply chain, it's always hard things, your literal hardware, things of that nature. But that's not necessarily the case in newer environments, because the software and the things that software are part of are just as much a part of that supply chain. So I'll split it into two. So from a hardware perspective, we're blessed with having the ability and scale to operate at very large quantities. That allows us also the ability to have many suppliers. It also allows us the ability to design and create our own hardware. And when I say hardware, I'm going to use it generically for firmware and all the other pieces and parts that lead up to that. So in that space, it allows us all of this capability that makes it much more difficult from a supply chain environment to target it. You may think, oh, many suppliers, that means you have many different avenues in. You would think that, but the thing is that every one of our suppliers is actually supplying us with things that we've specified, we've qualified up front, and we know exactly what it is. Meaning that, in many cases, our own intellectual property is being licensed out to these providers in order to be able to sell us stuff, as well as our own contract manufacturers or our own people. So we have this process in place that allows us to know what it's supposed to be and what it's supposed to do, because in many cases we've engineered it, we've designed it. As part of that qualification that starts up early, then following on behind that, whenever we receive things, we have an entire process that we go through that includes verifying that to make sure that it is what it's supposed to be. And how we do that is, in many cases, via software base. So we'll actually go through. The first thing we do, which many of you will probably understand, is that we don't trust what we get. We reflash everything from scratch. So everything comes in, regardless of what it may be, and it gets built from the ground up. And then it goes into a burn-in period of time. And once that's up and running, you're in a situation where you have a known true good, and then you can work from there. From my past life, I was a computer crime investigator and worked in various space. One of the things in counterintelligence, trying to keep people from spying on us, or if they were to catch them. And in that space, one of the things that they would intentionally do, these adversaries, is they would have to target. They would have to figure out where is the hardware going to be so that we can put an implant on it, and that way it'll end up being in this entity so we can get data from them. The scale that I was speaking of earlier allows us a great obfuscation layer, meaning that it's very difficult to be able to target whose data, where, how, what, if you were to even try to go into that space. Not saying it's impossible, but we definitely have a lot of those things in place, and many others that I'm not actually going to speak to you about today. Let me go on to software. So from a software perspective, we have a very robust application security process. We get into a situation where a lot of new environments are starting to talk about DevOps. And many of you are probably moving towards a DevOps type of environment. And one of the things that DevOps gives you is the ability to innovate and to move very quickly, as well as many of the other benefits that come along with it. One of the things that it causes a little bit of churn on is that if you use your old security environment in the way that you traditionally had, what you're going to miss is that you're going to go down to the very end, and you're going to build all this software, and your developers are going to push it on, and normally you're going to have some sort of testing at the end. And that testing at the end, traditionally your AppSec or pen test groups are going to be the ones trying to find those things that were built into the process. So What we do and how we do it differently is we have our teams do SecDevOps or DevSecOps, however you want to put it, but I'll go with SecDevOps. And that is that iteratively, as part of the process, both we, the security team, as well as the developers themselves, iterate as they go along. An example of this in some of the tooling, going back to some of the earlier discussion we were talking about that we have that allows us to help in the space, is using things like Amazon Inspector in order to do iterative looks at the code, or much more than the code, the actual machine image that these things are being run on. And what this does is allows you to iteratively, throughout the process, find those failures, faults, and issues. And when you're finding them closer to when you created them, the engineers themselves can fix them. So where I'm going with all of this is that we spend tens of millions of dollars on application security and pen testers every year for all of those services and features that we push forward to you. And in that process, one of the things that are in that model, what we've done is we've changed it up so that we're not doing just penetration testing, for those of you that aren't familiar, right at the end. We're actually having engagements that start from the beginning, because the security group should not be a group of no. And if your security team is the group of no, you've got the wrong security team. Security should be an enabler, therefore we should be part of the process and the engineering all the way through. And when it comes to software, from a supply chain perspective, what we're doing is trying to make sure that we have the strongest capability all the way through that process. Which on the back side of that means that when we do penetration testing, the results that we get aren't low-hanging fruit or easy things to get. They are things that are very difficult. And those are the types of things we want to find when we're doing and spending the amount of time and effort that we do in that space.
So another question that we hear from our public sector customers, it's a key security topic, is insider threat. What would you tell someone in the audience who's thinking about moving to cloud computing when they start moving to that environment of no longer having that full control over their environment?
Well, I could ask them a question back, but rather than making it a question, I'll make it a statement. And that is that one of the things that we've realized, especially operating in a cloud environment, is that if you have individuals that have both physical and logical access, meaning they can physically touch the servers as well as log on to them and see what's on them, you now have an inadequate level of separation of duties. One of the tenets that we have from AWS across the board is that if you have logical access, say you're a data tech in a data center, you shall not have logical access, meaning you cannot log on to that system or those systems that are within that space. What does this do? We talked a minute ago about targeting. If you're unable to target or identify what's where, it makes it very difficult for you to determine what you're after, or if you're actually after something, you won't know where it is. This obfuscation, or this inability for people that are physically within the environment to be able to see what is there and who's the customer and all of that type of data makes it much less appealing for them to do anything with it. We have many controls that back that up from the standpoint of, we talk about hard drives. Hard drives or any storage devices don't leave our environment without being mulched or otherwise destroyed in a physical manner which the people that are guarding the facility can tell. So if a hard drive leaves intact, that's not a good thing. If a hard drive leaves mulched into little pieces, that's the way it's supposed to be. Let me see, there's some other things. One of the things, the biggest thing that I'll say is, and I've got kind of two, I think. One is that we take goals every year across our organization. And one of the goals that we've taken, and we've pushed, I should say, from a security environment, is that year over year, we've pushed the teams to decrease human access, or the ability for a human to access customer data by 80%. Year over year over year. What is that doing? If I tell you, you're running an environment, and I say decrease the amount of humans they have access to the data by 10%, you're going to cut 10% of the staff that has access to that. Just remove them from it, and that's easy. What security value have you added? Probably very little. If I tell you you have to remove 80% of the staff that has access to that data, you're going to be forced to innovate. You're going to be forced to create tooling that allows them access only to that specific thing that they need to have access to, and maybe only for a short period of time, the time that they need it. And if you do that year after year after year, guess what happens? you narrow the large scope of potential for insider threat or insider actors down more and more and more and more. So this is the type of thing that, that you need to, even in your own organizations, if you're trying to figure out how to decrease that threat, the threat vector or the risk, that's how you do it. You do things like that. Just one other quick thing, and I'll cognizant of time and we'll tell you as much as we can. But the other thing that we do is, from an insider threat perspective, is we're huge on automation. And that is that we love metrics within our company. We love data. Whenever you can, work with data, you're in a good position because you're going to be able to distill that data down to things that you can actually take action on. So as you might imagine, we have millions and millions of logs and other things that are floating around or being generated by all of your use of the cloud environments. And what we're actually doing is we're doing analysis of those accesses from our internal people, looking for things that are aberrations to the norm. Those aberrations to the norm, whatever they may be, because we've learned over time by looking through that data, we've created automations that will alert a human whenever one of those aberrations pops up. And that'll go to the security operations team that works for me. And they will actually look into each and every occurrence that's brought forward. And guess what? We have a feedback loop between what they find there to make the automations better or to create new ones. New things pop up, we actually add new things. You're probably thinking, oh, this is this signature-based analysis. It can't be only signature-based because of the scale that we operate on. So we're looking for aberrations. Those may be things where traffic spikes too high or traffic's too low. Not just individual little things or signatures that you may be looking for. Signatures will fail over time. You need to be looking at the changes or the things that are out of the norm.
So I'd like to dive deep a little bit on the automation piece that you spoke about. Customers have told us that they're very grateful when we reach out to them, for example, letting them know that their AWS credentials were found on GitHub, or that we've reached out to them, letting them know that it appeared on some port scanning that was happening from an EC2 instance. I assume we don't have legions mining GitHub or network flow data, but how does AWS leverage automation to secure itself and help customers secure their environments? Yeah,
so some of that goes back to what I was saying. What we'll do is we'll actually learn from these things. We'll actually use the cloud to secure the cloud. If you're operating in the cloud and you're getting the cloud amount of logs, it doesn't make any sense to try to pull them off of the cloud into your own sensor back home on-prem in order to try to do analysis of them. You should analyze it in the cloud where it's more at home, and you can actually get those indications that come out of that. Those indications, whether indications of compromise or threat intel that's created out of that, are things that you then use in order to alert humans when necessary. Although one of the things that I'll say, you can increase security by getting rid of humans, but obviously to some point you have to have some humans involved. The other thing is we continue to get the question about, we talked, you brought up the, there's got to be humans, security operations team on the backside of a lot of this stuff. And we continually get the ask for people to come visit. It used to be to come visit our data centers. And as soon as I, put out the decree, and my boss actually put out the decree, we don't do data center tours. I got in trouble, and I'll still say it today because I got in trouble enough, I might as well use it again. Tours are something you do on vacation. I don't vacation in your data center, don't vacation in mine, so we don't allow people into the data center because that's where your data is. You don't want people vacationing on your data. From that standpoint, you take it kind of a step forward. People can't see the data center, so they want to see our SOC, our Security Operations Center. Because I know when I was at the FBI, one of the things we built was an awesome SOC. It was like Spaceship Enterprise, the bridge. It was great. It had lots of screens and stuff like that. But one of the things I learned, and that we've learned over the years even at AWS, is that who's in that SOC at 2 a.m. that's answering the phone, and what are they able to do? It turns into kind of a call center. There's a phone to call, so there's somebody there, that's great. But what capability do they have? Normally, it's very hard to staff at 2 a.m. with the brightest minds or the people that know the exact details that you need. So we've kind of taken it to, a step to become a virtual SOC. Our software we've created with those indications and those looking for these aberrations, and made the software smart enough in order to, when anything is out of sorts, it calls us, it pages us. And not only does it page us through the ticketing system so that we can maintain state on everything, as part of that, it then creates almost a crowdsourced response from all of those entities that have something to do with that particular issue that's been brought up. So if it's networking based, obviously it calls in the networking people. If it's a certain service, it'll call them in. And from there, then you have the ability to have real experts that are on call that are responding to in near real time or within 5 minutes normally on average to be able to interject and figure out what the issues are. So rather than spending money, and this is just coming from me, take it with a grain of salt, rather than spending money on that big enterprise thing, spend it on making sure that everybody has good laptops, VPNs, and things like that in order to be able to log in and figure out, to look at their service, in our case, our version of the service health dashboard to see what's working and what's not. And we've learned some lessons over the years, and Charlie Bell, Senior Vice President over many of our services, is former NASA. I know we have a NASA JPL representative in the audience. So one of the things that we've taken from some of the lessons learned out of the Challenger, Challenger explosion was normally when these calls or these different types of reactions occur, these the SOC issue resolution environments, is what we'll actually do is we'll go ahead and as you jump on the call, whatever service or entity you're representing, you've checked your dashboard to see whether you're the response, you have a response to what's going on, and then to try to prove that you aren't the reason for it. Not the inverse. Don't come on and start pointing fingers. It's literally everybody has to prove or has to bring forward, nope, my service looks good, all of my metrics are the same as they should be. The ones that say no could either be the cause or they could be part of the effect. So that's the type of mentality. So once again, going back to kind of the question, we automate everything we possibly can, including down to where you don't need a physical room for it to happen in, because the physical room is actually bounding you and slowing you down. You're securing the cloud, or you're using the cloud. So use the cloud and the cloud methodologies in order to do that security as well.
So many of the public sector customers are governments or contractors that work for the government, and some of our public sectors are researchers at colleges and universities. Mm-hmm. These groups don't want to worry that AWS will mine their intellectual property. Yes. Or hand it over to various governments around the world. How AWS thinks about and handles customer privacy is really important. And I wonder if you can provide some color to that.
So yeah, I mean, there are those services out there that offer you capabilities for free. Then by you using those services for free, as part of the terms of service, you are giving them the right to be able to crawl your data for interesting things so they can market to you or otherwise. We aren't one of those. We charge you for the services by the hour, by the megabyte or gigabyte or whatever it may be. So we're not in that space. You own your data when it's in the cloud, straight up. You own it, we don't crawl it. I don't know how much more specific or clear I can be than that. You own the data. When you put data into a region, so a region is a cluster of data centers, for those of you that aren't steeped in all the AWS terminology, but that cluster of data centers, when you put your data in, we won't move it unless you ask us to by API call to move it to another region. So when it really comes down to it, you own your data, we don't crawl it. We have many different tools and techniques to allow you to even make sure that that we aren't able to do any of that. So if you look at the encryption capabilities that are inherent or available within our platform, you have Cloud HSM, so a literal hardware security module that's there for you to be able to use to be able to encrypt your data and manage the keys. And if we were to try to get the data out, it's FIPS 140-2 level 3. If we try to get the data out, it would actually zeroize, and none of us would have a good day then. So the environment is set up such that you have those tools and techniques or tools and abilities provided to you via services in most cases in order to be able to even protect against us. Even if you trust us, you want to verify that, and in this case, this allows you to be able to do so using those different things. There's actually the key management service as well, so more easily utilized environments, because many of the services are actually set up to be able to with a single API call or single click within the console to be able to use that. So there's all these different gradients of encryption that are available, or encryption services, which allow you the freedom to be able to encrypt the data. Therefore, not only are you maintaining the privacy of the data, you're also ensuring that we couldn't crawl it for, spamming you some other types of ads or something like that.
So you've touched on and described about the things that we do largely for responding and reacting to information. So how does AWS get ahead of the bad guys?
That's always fun. So trying to get ahead of the bad guys is the cat and mouse game that has gone on forever. We do have a dedicated threat intelligence team the nice thing about operating at scale, 16 regions around the globe, is that we also are aware of what's going on around the globe from that standpoint. We said how we're big into metrics and data, so we'll be watching those metrics and data globally. We have the security operations team that is watching those things globally as well. From that, as things start to occur wherever they may be, or as things start to be different than they were before. So this is how you get ahead, and I say ahead, it's maybe only by a very small bit. When you see changes within the environment, and that may mean a traffic spike, it may be less traffic, it may be the use of different types of traffic in aggregate, that you're paying attention. And those are the types of things that our threat intel group are looking at. And when I say they're looking at it, obviously 16 regions around the world, millions of instances. It's not like they're sitting there staring at a metrics deck. What we do is we automate everything that we learn possible as quickly as we can and push it into those tools such that they are looking on our behalf. Force multipliers in the cloud. So you take all of the capabilities that you have. If we tried to hire enough people to do it, first of all of our customers would be mad at us because we'd be stealing away, trying to compete with the same pool of small pool of security engineers that are out there. We don't want to do that. And whenever we want to make sure that everybody that's using the platform, getting the best bang for the buck out of them. And what we're doing is every bit of thing that we learn from operating the environment, we have the smallest feedback loop we possibly can to get them back into tools and services that will benefit all of us. One of those things is that if we can see something that's going on, and it's something that we can create a tool, add to a service, a pre-existing service, whether it's Inspector, AWS Shield, a lot of the configuration management tools that we have, so AWS config rules, you can go down the laundry list, adding to the CloudFormation templates, pushing that type of stuff out there such that we're in a situation where the noise floor changes. The signal-to-noise ratio, the more things that we can thwart at the edge or on the outside of the cloud environment or as it's occurring, the less things that all of you will have to deal with, and subsequently my operations team. So our threat intel team stays very busy and is very active in pushing these things to happen, both inside for the internal protection of the environment, as well as some of you may have gotten emails that have come out to say, hey, you have left this bucket on S3 wide open. Did you intend to do so? You'll see some of those things come out in Trusted Advisor. Other things that are more timely, things that are going on and we're seeing, we'll send those messages out as well. So those are the things that, even though it may be that it's on the customer side of the shared responsibility model, doesn't mean that we're not looking and trying to help in every way, shape, and form that we can. We definitely are, and continually trying to automate that such that those things can be done on your behalf and become, off your undifferentiated heavy lifting list in the future.
There's a lot of movement going on with security across industries. As AWS looks towards the future, where do you see the security landscape with respect to how it provides security of the cloud?
So, yeah, so we do have a team specifically for that. I mean, obviously, we're always at the forefront of what's going on. but knowing that we need people that are paying attention, single-threaded paying attention to what is the future, where do we need to be, what are the things that we can be doing today based upon looking at the future, or where things are going. We have an automated reasoning group, ARG as we like to call them. I still think they should have had a little pirate logo when they came up with that one, but they missed that one. They're advanced data and research scientists in the software environment, using mathematical proofs and formal verification of the software in order to prove, literally through mathematical algorithms, that software is doing what it's supposed to do and nothing else. I know this sounds all way too deep and mathy for many of you. It did for me when we were first going through it. Where it shows the benefit and the value is, if any of you are familiar with S2N, our TLS distribution that we've put out, it's intentionally very bare bones. And one of the things that you should know about it is that we've run formal proofs, formal verification of every routine that it runs, such that we know through mathematical certainty that it's doing what it's supposed to do and nothing else. So on every call, it's doing what it's supposed to do. The nice thing is that when we first ran it, there were things that weren't coming back proofed before it was launched publicly, of course. And we found things, and we made sure that there weren't any of those things that were sticking out before it was launched out to the public. That's the kind of thing that we're advancing, continuing to push that scope of the various things that are out there that we can do. I think that'll become more, become some of the things that you'll see in the future. Some companies are starting to look in it more and more. We've doubled down in that space because we've seen the benefits.
So CJ, you talked a lot about AWS, what AWS delivers for the security of the cloud. Why should customers believe you or anyone at AWS if we're really doing all these things? I get this question all the time.
Well, the answer is they shouldn't. And it's interesting, it's coming from you, security assurance, our compliance team lead. But the reality is, I said it earlier, it's trust but verify. It comes down to being able to do that verification. Statistics that Jen and Chad, our compliance leader that's in the audience, this team, the compliance and security automation or security assurance team, have done a great job. We have dozens, I don't know how many dozens, but there's dozens of different frameworks that the team has put together, over 40 of our different services, covering 2,700 plus controls, and get me, if I get numbers wrong, jump in. 30 million instances worth of proofs on these various different things. And much of this is done via third-party auditors. So it's not even trusting the compliance team that's paid for by AWS. The third-party auditors. If you think of the different frameworks I was talking about, we're talking about the FedRAMP that many of you will be very familiar with. So there are third-party auditors that come in on their behalf. We may have to pay them, but they're working definitely on your behalf, that come in and do that testing. It's gotten so, so forward that we have so many of them that we're continuously under audit by third-party auditors, along with our own internal teams that are doing it, Jen and team. So we're in a situation where, talk about continuous audit and verification. You have third-party auditors that are auditing on your behalf and pushing that data out through various different sources, AWS Artifact and other things like that, to allow you to be able to get the benefit of that. So, I'd love to say that you should just trust me because I'm a nice guy and I'm not going to lie to you, but the reality is that you probably wouldn't anyways, and you'd turn around and want verification. So, going back to the Russian proverb that Ronald Reagan made so infamous, trust but verify. We're good with that, and we have stacks and stacks. Hopefully, you don't want it printed out. You get it in the electronic version. It is the cloud. We do like to use electronics to actually get that verification and not have to trust us directly.
So now that we talked a lot about what AWS does to protect the cloud, let's go back to the customers shared security responsibility model. I've met with many customers, and they come up with a story that sounds something like this, and I'm sure you're familiar with that. They have a smart person on their team, and they had a great idea. They grabbed a server, they put it underneath their desk, and then they left the company. Nobody knows what to do with the server, so they're afraid to unplug it. And they don't have access to it, and they can't patch it. So how does AWS help customers make these more general issues, governance and the visibility to provide them?
So, back in the government days, I definitely can, feel for this person because, if you, when I was going out trying to find these hackers, you had IP addresses, and you go to a certain location, I won't name any names, and ask them where such and such server is, and they wouldn't have any idea. It's registered to them, but physically they don't know where it is on the campus or otherwise. So your number one thing that you have to do, in order to be able to be secure, you have to have visibility into the environment that you have. In this case, what you have is you may now have some visibility, but not all the visibility you need. You know there's a computer under the desk. That's actually a good step, the fact that they even knew that. In our environment, that visibility is an API call or a console click away. That's the number one thing, is being able to know what is there, what's deployed, what image is running in those environments, and then you can take the next steps thereafter. For the individual that has the thing under their desk, we can't help them in order to determine whether it's a good, bad, or indifferent, but I would say that they got to deal with it. But in the cloud environment, we have a plethora of tools to be able to allow you to be able to do that. We can go down many different roads. The number one thing I say is automation. In the government, I remember the idea, and it still holds true somewhat today, the idea of a gold image. And that gold image used to be, the operating system and the applications that you use, and you created this gold image and it got blessed, and that's what you use throughout the agency or otherwise. We're now in the cloud, and yes, you can have an Amazon machine image that is the gold image. Take it further than that, because guess what? That's not the only security area that you have, or security risk or threat area that you have. It's much larger than that. Why don't we gold image the data center? And what I mean by that is use CloudFormation or other services that we provide in order to templatize everything that you do. All of those pieces and parts. You should be able to click a button, and 5 minutes later, your entire data center, your virtual data center in this case, is replicated. As part of being able to do that, you learn iteratively of the things that are good and bad. And you change the template for the good, and you continue to do that. So in this environment, that's part of the thing that you really need to take advantage of. Embrace the cloud from an automation standpoint. Templatize. Don't templatize on an image, well, like we used to do. Now templatize larger. All of those pieces and parts, the virtual routers, the different storage environments, such that you can recreate it on a moment's notice. One of the things, and I know we're running out of time really quickly, but I'll throw this one in there. Went to the Naval War College, and one of the things for the very first time we were doing is we were actually doing wargaming based upon a cyber attack, disabling the ability of the Navy to actually sail to a physical true threat. And one of the things that they brought forward was that this data center that was supporting the actual ships, that wouldn't allow the ships to move without that data center, had an attack, and that attack was an advanced persistent threat, an APT. Advanced persistent, meaning that it's going to stay, likely. And the only way to get rid of it is pretty much, shy of various things that are out there, pretty much start fresh and all over again. And oh yeah, the ships have to go now. What do? I threw him a big, boomerang on this one. I said, well, I'm just going to launch my CloudFormation template, and I'm going to launch a whole new instance of that without the APT in there. I'm going to pull over all non-executable data into the new environment. 15 minutes, those ships can be on their way. They were like, whoa! The reality is that you have to embrace the new technology because the adversaries have already done so. So the idea being is that you're using the technology for the greater good, not holding on to the old technology, which is going to hurt you in all that you do over time. So.
Thank you, CJ. Before we end, I'd like to ask one more question for you from the audience. As we look into the coming years, where do you think we'll see major movements in security for AWS, for the industry, and for customers?
We've traditionally seen, there's a lot of different things. One of the things that we've been saying for years, and we're starting to see more, is the shrinking perimeter. The days of protecting only your network should be gone. I know that it still is a good hygiene, if you will. It's not saying that your network around your environment shouldn't have protections in it. But if you're relying only on those and the firewall on the outside, you're once again holding on to past ways of doing things. Those perimeters are decreasing around you, or we like to call it having tiny bubbles. So blast radius is very small. In the cloud environment, you're allowed to have obviously policies. You can get so granular with those defenses, if you will, or defense in depth, that you'll be able to be more resilient to attacks than otherwise. The thing that kind of jumps out from, on this is that you have things like workspaces, so our VDI or virtual desktop in the cloud environments. We have customers that are literally taking those, using workspaces in order to get those those desktops out of their environment, because it actually decreases the attack surface within their environment as it is, because it's now running in the cloud. The nice thing is that you're going to see, and this is, I'll guarantee it because it's already happening, is your environments, your networks that are zero trust, such that you can actually take your laptop or your whatever device you may have, go to the nearest coffee establishment, sit down with your device, and be able to log in and do things over that network and still do it in a secure manner. There's lots of technologies that are enabling that. Some of those technologies are here today. Some of those are still being worked on. But the reality is that zero trust networks are the wave of the future, and it's also the wave of the future for those of us that have kids that have better capabilities at home on their whatever pad than some of us used to have or still do have working in government circles. When they have more, when your kids have better technology than you have, you got a problem and you need to fix it. So that idea of zero trust networks, or the ability to have that, allows you to be able to spend your money towards other things. And those other things would be the newer technologies that actually are data-centric security rather than network-centric security.
Thank you, CJ. Let's give CJ a round of applause for spending his time in this busy afternoon. Thank you.
Thank you.